Okay? So that's probably not going to work very well to just type those into the calculator. But let's use that idea that we talked about before. Okay? So Carl Friedrich Gauss said, hey, if I've got this arithmetic sequence, if I've got these numbers that are just getting larger and larger and larger, or smaller and smaller and smaller by the exact same amount every time, we call that a common difference, remember, I could rewrite the list. So I'm going to take this list and rewrite it. This is going to be 700. This is going to be 693. Let's see, this would be 686. And then the last couple in the list would be, let's see, 364 and 357. Okay, and if I add those up, so let's just check these. This would be 1057, am I right? If I add those together, guess what I get? 1057. Okay, and keep going. Every one of these is going to be 1057. So we're kind of piggybacking on his idea. And we've made a list here where all of the numbers are exactly the same. And if all the numbers are exactly the same and you need to add them up, you don't do an addition problem, you do a multiplication problem, don't you? Isn't repeated addition just multiplication? 5 times 7 means 7 plus 7 plus 7 plus 7 plus 7. Okay, or 5 plus 5 plus 5 7 times, right? So how many of these are there? How many of these 1057s are there? Okay, well, let's think here. So you've got to really think about this. Plug in a 51, that's the first one. Plug in a 52, that's the second one. Plug in a 53, that's the third one. Okay, this is not a silly exercise. Even if you know what the answer is, please don't look at the indices and say, oh, I know how many there are. Because if it starts with a number other than 1, you've got to really think about this. So if I start at 1 and I count up to 100, how many numbers are there from 51, including 51 up to 100? There'd be 50, okay? So there would be 50 of these numbers right there. So I'm going to take 50 times 1057. That's going to give me an answer, but is it the answer to the problem? It's not the answer to the problem, because we added up 2 of the exact same list, one forward and one in reverse. Okay? So I'm going to take that answer, 50 times 1057, and I'm going to divide by 2, and that's going to give me the actual answer. So if I do 25 times 2057, what do I end up with? 26425. Is that right? Okay. Any questions there? Is that the only way to do the problem? No. It's not. Okay? The other way to do the problem is to stop and think about, what does that formula mean? When we write down the sum of the first n terms, or the nth partial sum, is going to be the number of terms divided by 2 plus the first term times the nth term. Another way to think of this is, this is the first one, this is the last one, and this n right here is the number of terms. Haven't we figured this out already? How many terms are there? There are 50. Divide that by 2. What's the first term? What you get when you plug in a 51, so that's 357. What's the last term? It's what you get when you plug in a 100, so that's going to be 700. Multiply those together. That's exactly the same problem that we just did, isn't it? Does that make sense? Okay. Any questions? Okay. Sure? Okay. Let's take a look at problem number 65. Okay, on problem number 65, we've got the sum from 11 to 30. Whoops. Okay. And then we're going to subtract the sum from 1 to 10. It's the same formula. These are just the counting numbers. So this is going to be 11 plus 12 plus ... all the way up to 29 plus 30. And we're going to do the same thing. Now the nice thing about this is, we're starting with a 1 in the ones place right here, just like we did right here. So remember, when I plug in a 51, that's the first term, 52, that's the second term, and so forth. So if I plug in an 11, that's the first term. If I plug in a 12, that's the second term. So how many terms are there, including the 11, all the way up to and including the 30th one? There are 20. What would be a quicker way to figure this out? Could we make a rule where we could figure out how many terms there are based on what the upper limit is and what the lower limit is for the index? Could we make a rule where we could look at the upper limit and the lower limit and we could figure out, okay, how many terms are there? Alexis? Okay, upper one minus the bottom one and then add one. Or another way to think of it would be take the upper one and subtract one less than the lower limit here. So on this one we'd do 100 minus 50, there's 50 terms. On this one we'd do 30 minus not 11 because we're going to include the 11 because that's part of the numbers, the indices that we plug in. So we subtract 10, so that's going to give us 20, okay? So this is a little bit silly on this problem right here, but does it still work? If I do 10 and I subtract 0, how many terms are there from 1 to 10? 10. Does that make sense? Okay. Can you figure out these answers? 20 terms, whoops, divide that by 2, I'm thinking ahead of the answer, okay? First term's 11, last term's 30. And on this one, 10 terms, divide by 2. First one is 1, last one is 10. Throw that into the calculator and you'll have your answer. Okay, are there any questions? Okay, what'd you get on this one? 355. Okay, any questions? All right, grab your calculator if you would, please. We talked about a formula last time that looked like this. Sum, sequence, and then it was, okay, we had to put in a formula, okay? So I'm going to put in a sub n, and then we had to tell it what the variable was, and then we tell it the start of the index, and then where we stop, okay? So I'm going to use, let's see, I'll put an I into a J or something like that. Okay, so this is the formula for the nth term. And this tells us what we're using. This is the variable for the index. And this is index, oops. Index starts here and ends here. Okay. Now I think I did one of these at the end of class on Friday. Okay. You can type in the formula in ends if you want. It's a little bit easier if you use X's because you have an X button already available on your calculator. So here's what we're going to do. We're going to do this problem right here. And we're going to have it first of all spit out this list of numbers for us. So grab the calculator. Okay. Anybody remember where we find this? Okay, second stat, it's under the list. So we're going to do second stat. The first thing we're going to do is we're going to have it make the sequence for us. So we're just going to have it display the correct numbers. All right? So under second stat, under the list menu, go to ops, and it has sequence. So this is just an operation. It's just going to make the sequence for us. So we're going to do this. The sequence we want it to make is 357, then 364, and then 371. We want it to, our little formula is 7 times n. So I'm going to type a 7, and then I'm going to do an x instead of an n. If you want to do an n, you're welcome to. Hit a comma, and then you have to tell the calculator what index are we using? What is the variable we're using for our index? So we're going to use an x. Then you have to tell it, what index do you want me to start with? What number do you want me to start with? We want to start with 51. and then we hit a comma and we tell it what we stop with. We stop when we plug in a 100. It knows that it's supposed to count up by 1. It knows to plug in a 51, then a 52, then a 53. It's not going to do a 51, then a 51.4, and then a 51.8 or something like that. Okay? So if we have the correct command again, and notice that it does this really quickly, it should make a list of numbers. It should make the sequence that we're after, that we want to add up to make the series. Any questions there? Okay. We could also do this, okay? Hit second enter, close the parentheses, and if you wanted to, you could hit the store button, and above the 1, 2, 3, 4, 5, and 6 are lists. They say L1, L2, and so forth. So I could hit second L1. I could hit that. It creates the list and then it stores it. So if we wanted to look at all of them in a nice convenient place, okay, go ahead and hit the stat button, not second stat, just the stat button. And there's that list of numbers. You could go down and you could check all of them out. Okay? You could sum them up in a lot of different places. Okay? So I'm going to clear this off, and we're going to go ahead and we're going to find the sum. So hit second list. We're going to do some math. We're going to sum these up. So under second list, it has names, ops, and math. We're going to go to maths because we're going to sum these up. Okay, let me slide this over here so we can see what this is. And then we're going to sum a sequence of numbers. So we hit second list again, and we're going to make this again. We could have recalled that before, but it's good practice to type that in. So this is what we're going to sum. We're going to sum this sequence, and the sequence is 7x, comma, the index, the thing that changes every time, is an x. Hit a comma. The index we start off with is 51, and we stop when we plug in a 100. If you wanted to close the parentheses a couple times, you could. Now, if we did this right, this better give us 26,425, right? It's going to work for a minute. Okay, think about what it did. It just wrote down those 50 numbers, figured out what they were, and it added them all together that quick. Got the right answer there. Any questions? Sure? Okay, so everybody got the calculator figured out? Okay, let's do this one right here. Add this one up, and then do a little subtraction problem, or it might be kind of cool if you could do it all in one single list. If you weren't interested in practicing typing these numbers in again or typing these commands in and stuff like this, what's the easiest way to get this answer? How about recall this and let's edit it. Isn't it n? Or we're going to use an x. The variable is x. Start by plugging in an 11. Stop when you plug in a 30. And I'll delete that. There's that sum. And then all I have to do is recall this. Oops. There we go. And I want to go from 1, I'm going to delete that, to 10. So if I do 410 minus 55, let's see. Oh yeah, 410 minus 55 would be 355, yep. The 410 minus 55, 355 right there, okay? Pretty easy once you type the command in and you get used to where to find stuff. Okay, any questions? Okay, let me show you just one more thing. You don't have to do this. Okay, can I erase the screen? I'm going to clear this off. I'm going to hit the stat button and it says edit. So I'm just going to look at what's in L1. There are all those numbers. We could go down and we could check all of them out. There are 50 of them. I'm going to hit second quit and I'm going to do this. I'm going to hit second list. I'm going to go to the math and I'm going to grab the sum and I'm going to tell it to sum the stuff in L1. And the stuff in L1 was that list of numbers that we figured out on 64. So it adds them up that quickly. Okay? So several different ways you can approach that problem. Okay? Any questions? Okay. Nothing else on 9.2? Raise your hand if you're done. Very good. Okay. Go ahead and put that away then, if you would.